So, the top of this page goes back to the calculator because in the end we're going to use our calculator to solve some of these, but right now we're going to do it by hand at first because that's what we've been doing is solving these by hand. So let me zoom this in a little bit, make it a little bigger. Okay, so it says consider the function f of x equals 2 over x minus 1. Set up and solve to determine when f of x equals 4. So this is f of x and they want it to equal 4. So we're going to set this function equal to 4. So 2 over x minus 1 equals 4. So far so good? Alright, so we just did this. We wrote the equation. Now it says multiply both sides by the denominator or the LCD, because it happens to be the LCD in this case. We're clearing the fraction, right? So you can say multiply by the denominator, multiply by, I'm going to say LCD just because it's an abbreviation. Multiply by the LCD, which in this case happens to be x minus 1. So I'm going to multiply both sides of this equation. And the reason we're doing that is to clear the fraction, which is the next step, which says cancel common factors on the left. That would be those two. And distribute on the right. So on the left I would be left with a 2. And on the right I would have 4x minus 4. So far so good? Alright, add the opposite to both sides. Now this is one of those things that probably that terminology might not be what you would say. But we're solving for x here. So in this case, if we're solving this for x, what do we do? Add 4. So that's what they mean, add the opposite. It's a minus 4, so add 4 to both sides. So that gives me 6 equals 4x. And then I'm still just solving for x, so what do I do next?
Divide by 4.
Divide by 4. And I get x equals 3 halves. Okay, so is everybody okay so far? Okay. Now, consider the inequality. Now, is this any different than what we just did up here?
Not really.
What's it? So here's this.
The only thing that changed was
The sign, and now it's just a greater than or equal to sign. That's the only difference. The steps are all going to be exactly the same because we solve inequalities just like we solve regular equations. So there's my inequality. 2 over x minus 1 is greater than or equal to 4. Multiply both sides by the LCD, which happen to be x minus 1. Which then we canceled the common factors, and that left 2 and 4x minus 4. This time it just happens to be greater than or equal to. Add 4 to both sides. So I get 6 is greater than or equal to 4x. And then divide both sides by 4. And I get 3 halves is greater than or equal to x. Is everybody okay? And then they gave me another one, or they just flipped it around. So 3 halves is greater than or equal to x is the same thing as x is less than or equal to 3 halves. Is everybody okay with that flipping around thing?
yes.
All right. With, big mouth is open to the 3 halves, big mouth still open to 3 halves with it. Okay. All right. So solving the inequality rather than the steps to solving the inequality rather than the equation are exactly the same, are they not? I even did them in the same color, see? I mean, they're exactly the same. Yes?
Good.
However, this solution is not correct.
Why?
That's what we're about to try to figure out.
Not
So we are going to use the table on our calculator to see if we can figure out why. So go ahead and get your calculator out.
my calculator. I don't even remember the last time I started it.
My calculator's red.
Ugh, I haven't deleted it so much. I haven't charged mine since we got back from the break.
Oh, wow.
Yeah, I think that's the last time I charged.
Cool shading.
Hi, Kevin. Are we typing in the
If you
equation?
haven't turned it on in a long time, it takes a long, it has to load that first time.
Are we typing in the equation?
We are typing in 2 over,
Oh, we not put the sign?
no, don't type in the sign right now.
Okay.
Because we just want the table. And if you type in the, by the way, I'm glad you brought that up. If you type in that, if you do an inequality, it won't produce a table for you. Because it only can produce a table if what you put in is a function. And when you put an inequality sign, it's no longer a function. So I need this table here. Now my table is not, their table is counting by halves, and mine's not. So I want it to be. So I'm going to hit menu, 2, 5, and I'm going to change my table settings, my table step, to count by 0.5s, because that's what theirs is counting by. Okay, so there I can fill in my table just like they have theirs. So -2, -4, undefined. Now it says use your calculator to complete the table. I just did that. On your table, circle the entries where x is less than or equal to 1.5. So here's x is 1.5. All of these are less than 1.5, yes? I mean, this one equals, this is where x equals 1.5, and then all of those are where x is less than 1.5, yeah? Everybody good? Okay, then the next thing says, on the table, shade the entries where f of x is greater than or equal to 4. What does f of x mean? Y. So I'm looking for where y is greater than 4, greater than or equal to 4. I don't have anywhere where it's greater. I only have one place where it's equal to. Now, do these two sections match up? No. I mean, yes and no. They match up right here, but this said, when we solved this problem out, it said where x is less than or equal to. Not just where x is equal to. It's equal right here. But it said the answers, all the answers less than 1.5 would work. And this doesn't work. That's less than 1.5. And that doesn't work. And that's less than 1.5. And that doesn't work. So the two areas don't really match up. So we're going to see if we can figure out why. So no, they don't. The only place where it matches up is at 1.5, and that happens to equal 4, but the rest of it doesn't work. So if you flip over on the back, the algebraic solution that we solved by hand and got x is less than or equal to 1.5 doesn't seem to agree with the tabular or the table solutions. So it says a better table may provide more information for us. So look at what they've done to your table now. Now we're no longer counting by 0.5s. What are we counting by? 0.1, right?
I was going to say that, but
So I'm going to change my table setting again. So I'm going to menu, 2 for table, 5 for edit table settings. I'm going to go ahead and change my table to start where theirs does, which is at 0.8. And I'm going to count by 0.1s. So now I can just fill in my table. So now they're going to have us do the exact same thing we did just a minute ago. On the table, circle the entries where x is less than 1.5. So x is 1. here's 1.5. All of those have to be less than 1.5. And shade where f of x is 4 or greater. No? Now this time, I actually have more answers that line up. It doesn't match up from here on, but all of these match up. So the sections match up between 1.1 and 4, or actually, probably, I don't know because I didn't, but I can do it real quick and change my table and just see. What if I counted by 0.01s, and so I had more decimals? Let's see. I'm going to do that. You don't have to, but I'm going to real quick and then we can look at it online. Okay, so 1 is still undefined, but look at 1.01.
I was gonna.
200, 166.
So
those are all greater than 4, right? So everything's greater than 4 until I hit 1. Why do you think that is? What is 1 on this particular problem? Why would it be undefined? What is it?
Is that what
I don't know the word for it.
You know the word
It's the
for
whole
it.
thing.
It's not a hole.
The vertical.
It's the vertical asymptote. Look at your equation.
Oh,
Oh.
I said if you start with a
1 is the asymptote, right?
Yeah.
So everything up until 1 is greater than 4. But then when we get to the asymptote, it doesn't work anymore. Because it had to jump, right? It had to jump and go somewhere else. So that's what the problem is. So it does say, by the way, what happens at x equals 1. The vertical asymptote is what happens. So right here, where the sections match up, where the circle and the highlighting meets, is from 1 to 1.5. Now I put the 1 in parentheses because at 1 it's undefined. That didn't work. But y'all saw 1.01 worked, and I bet 1.001 works. I mean, I can go change my table and see, but I'm pretty sure it probably does. So the actual solution to the inequality is not only where x is less than or equal to 1.5, but also where x is greater than 1. Because that's the asymptote. Okay, so all you're doing is solving an inequality, but because these are rational inequalities and have asymptotes, we have to take that into consideration when we come up with our answers. So we're going to use our graph to determine the intervals where the given inequalities are true. So they gave us 2 points on the same graph. The reason that we're actually going to use the graph and sometimes use your calculator is because it's easier to see it when you have the asymptote to see how it works. So they're asking me about point A. Here's point A. The equation f of x equals 1 has the solution x equals 3. Okay, that just means that I have an ordered pair 3, 1. That's all they just told me. Over what intervals is f of x greater than or equal to 1? Now, whenever they write something like this, yes, it means y. Where are the y values greater than or equal to 1? They specifically mean the y values of this graph. So you could take this notation to mean, you could read this as, where is the graph greater than 1? Well, it's super, super easy to find because f of x equals 1 is right here. Right? I just drew it in purple. That's f of x that it equals 1. I am just looking for the piece of graph that's greater than that. Where would it be? F of x is y. Where would the greater numbers be? Above, right? Above. Above that dotted line. That's it. That's all you're looking for. The graph is above that dotted line from here to here. Does everybody agree with that?
Yes.
Was that difficult?
No.
No. Now the only part about this that is even remotely difficult is when they say the word interval, they mean x values only. All they want to know is what are the x values where the y value is greater than 1. So that part gets a little bit crazy because you have to think about the x values between here and here. This one's easy. That one's 3 because it's right there. But what's this x value over here? 1. Now does 1 get to be included? No, because it's the asymptote, so it's going to be parentheses 1, comma, 3,
Close.
bracket, yes,
bracket.
closed bracket, because it's actually a solid dot and because this has a line underneath. Okay, so we good? Okay, so now we get to move to the next bullet, which just asks us, over what interval is f of x, meaning the graph, less than 1? Graphically, that would be below the dotted line that we drew. So that would be, now it's below right here, but it is also below
Right.
all
There.
of this.
Oh.
So there are 2 separate pieces where it's below, which means when I write the interval notation, I will have 2 separate pieces. And because we read from left to right, let's start with the leftmost piece. This piece, the x values that are represented by this piece of blue graph, would be negative infinity to
2 was 0.
1. Well, it actually crosses the axis
Oh.
at 0, and it's headed towards
1.
1. It's headed towards the asymptote. So is it going to touch it?
No.
Nope. So it's going to be a parentheses. In union with, starting right here at 3, do I get to include that?
You knew why, yes.
Yes, you do. Why?
Because you just have to.
Because it has a line underneath it right here, less than or equal to 3. And it does equal 3 right there. That's a solid dot right there. So it equals 3. Everybody okay?
Man, I need to go to my little bins.
All right. Now we're going to do the same thing on the graph, but now we're using point B as our guide. So this point down here is your guide. Now we're using -2. So I'm going to give you a second to try it. You try, and then we'll see how you did. I don't think I ever took roll. Okay, so I just started by drawing in a line at -2 so I could easily see where this is. It asks me, on what intervals is f of x greater than -2. So I'm looking for all of the places that the graph, that would be f of x, is above the dotted line that I drew. So it's above right here and all of this right here. Two separate pieces of graph, two separate pieces of interval that I'm going to have to write. And the only thing you have to be cautious about on this one is, even though that -2 is not an asymptote, it does not get to be included either. Because they just said f of x is greater than -2. They didn't say f of x gets to equal -2. So when I write this, I have to take that into consideration. Alright, so this little piece goes from -infinity to 0, because remember, we're talking x values only. Not y values, but the x value. And then it starts over again after the asymptote and goes from 1 to infinity. Now they asked me to show it symbolically and on a number line. So this on a number line would be, there's a 0, open dot, that's shaded to the left, that's -infinity to 0, and then open dot at 1, shaded to infinity. And then the next question is, where is it less than -2? That would just be this piece right here. Where is it below that orange dotted line? Just that tiny little piece right there, which is just from 0 to 1. None of it can be included because of they didn't put an equal sign underneath. So if I was doing that on a number line, it would be 0 to 1, both of them open dots, shaded in the middle. I don't know if y'all noticed the number 1 part of it. That's pretty easy. If you can do the interval notation, you can do the number 1. Is everybody okay? It's not too bad. So I don't know what they were talking about in the class period. I just like to scare you guys. This is exactly the same thing. Just exactly what we did.
Maybe they don't listen.
Sometimes that is definitely the problem, I would say.